Hello everyone, we're from Group 4 with the members are Aliana, Haya, Zafira, Fatia Aziza, and Aulia Normasari. We're gonna talk about the application of metrics in our real life to fulfill the final semester project of Metrics Algebra course. So in our real life, metrics is used to solve many problems. For example, for For example, is to find the solution in linear equation system problem.
Hi, I'm Aulia. Now I will tell you about example of applied metric. First, make it easy to analyze an economic problem that contains a variety of variables. Second, use in solving the problem about investigation operations. For example, the problem of investigation of petroleum source and so on. Third, connect with the use of linear programming, input-output analysis both in economics, statistics, and in the fields of education, management, chemistry, and other technological fields. We have a problem that we can use metric to solve it. Here, Fatia and Aya buy orange, salad, and apples at the same fruit shop on different days. Haya bought 1 kilogram of orange, 3 kilogram of salad, and 2 kilogram of apples for a total price of 33,000 rupiah. Fatia bought 2 kilogram of orange, 1 kilogram of salad, and 1 kilogram of apples for a total of 23,500 rupiah. And Aya bought 1 kilogram of orange, 2 kilogram of salad, and 3 kilogram of apples with a total price of 36,500. What is the price per kilogram of each fruit they buy? Okay, we have two ways to solve the problem that we have. First, with Gauss elimination. Second, with Cramer's rule. What is the meaning of Gauss elimination method? Gaussian elimination is a method to operate on the values in the metric so that it becomes a simpler metric by performing elementary row operations so that the metric becomes a row echelon metric. This can be used as a method of solving linear equations using matrices. Steps to solve metric with Gaussian elimination. First, change the system of equations into an augmented metric. Second, perform ERO or elementary row operations on the metric so that a row echelon metric is formed. Third, do back substitution to get the value of the existing variables. Okay, I think enough. I think enough. And the solution of the problem that we have will be explained by the next presenter.
So next we will solve the problem that we have before from the explanation that we explained. So the solution is use Gauss elimination. The step one is from the problem let orange is equal to G, salad is equal to S, and apple is equal to A. Step two, then we have a linear equation system. The first equation is G plus 3S plus 2A is equal to 33,000. The second equation is 2G plus S plus A is equal to 23 and 500. And last equation is G plus 2S plus 3A is equal to 36 and 500. The third step is change the system of equation into an augmented matrix. So this is the augmented matrix from equation into an augmented matrix. So next step, do the arrow or elementary row operation on the matrix so that a row as one matrix is formed. So the second step is a second step. The first step is matrix 1 3 2 2 1 1 2 1 2 3. So we will uh, the row 2 minus 2 times row 1. So we will from the matrix to the this to this matrix. The diagonal is 1 and under the diagonal is 0. So step 1 is row 2 minus 2 times row 1. So we got this. We got we got 0 in row 2. So next row 3 minus row 1. So we get the second 0. Next step row 2 per minus 5 and we will get 1 in the middle of matrix. So we got 1 in here and we will addition. Row 3 plus row 2 and we got plus 0 in here. And last step we will times the row 3 with 5 per 8. So we will get this matrix that the diagonal is 1 and under the diagonal is 0. So the answer from the problem, we will from the matrix to back to the linear equation. So we have, and this is coefficient. What is coefficient? GSA. So is from G plus 3S plus 2A is equal to 33,000. So S plus 3 per 5 A is equal to 8,500. So we get A is equal to 7,500. 5 to the substitution from A is equal to 7,500. S plus 3 per 5A is equal to 8,500 from this one. So S plus 3 per 5 times 7,500 is equal to 8,500. So S is 4,000 and we will substitute to this equation and then we got the G. We got the G is 6,000. So the price is orange. So the price of orange is 6 rupiah. Salad is 4,000 rupiah, and apple is 7,500 rupiah per kilogram. This orange salad and apples. Back to this one JSA. Orange salad and apple. Okay.
Okay, next we're gonna talk about the Cramer's rule. So the definition of Cramer's rule is a formula that can be used to solve system of linear equation. This method uses the determinant of a matrix and another matrix, which is obtained by replacing one of the columns with a factor consisting of the numbers to the right of the equation. So for a linear equation system 3 times 3, where determinant is not equal to 0, the solution are x. The x is equal to ax, determinant of ax, over determinant of a, and then y is determinant of ay over determinant of a, and z is equal to determinant of az over determinant of a. So if we want to find the solution set of a linear equation system, we have to find the determinant of a coefficient matrix first. Then if the determinant of coefficient matrix is not equal to 0, then we can use Cramer's rule to find the solution set. Then the next step is we have to find the determinant of ax and determinant of ay and determinant of az. And next, to find the determinant to find the determinant, we can use cofactor and minor rows. So the minor of any element in a determinant A is obtained by omitting from A the row and the column containing the element. For example, in the determinant A, so if we have the determinant of matrix A 3 times 3, then the minor of A row 1, column 1 is like this. So we have to close, or we have to remove the column 1 and row 1 and column 1, then we got this A2, A23, A32, and A33, that of and so on. And then the cofactor of any element in a determinant is its coefficient in the expansion of the determinant. It is therefore equal to the corresponding minor with the proper sign. The sign of the cofactor of an element in the ith row or jth column is -1 or power I plus g. For example, the cofactor of row R, and column S of the element A row R, and column S in a determinant A is its coefficient in the expansion of A and is defined by the relation cofactor Rs is equal to -1 power R plus S times minor Rs, where minor Rs is the minor of ARS in determinant of A. So if we want to find determinant of A, where the row is 3 and the column is 3, the steps are: first, choose one row or one column as a basis for finding a determinant. For example, we choose first row, which are A11, A12, and A13. Then determinant A is A11 times cofactor A11 and so on, where cofactor Rs is like this and minor Rs is the determinant of element matrix A, which has been removed its row R and column S. For example, we choose first row for step 1, then determinant of A is the A11, factor A11, and we can divide it to like this, and we got power 2, power 3, and power 4, and we can also tell each minor like this. If we want to find the minor of A11, then we have to close the row 1 and column 1. Then we got this for the determinant of A11. And also the minor of A12 is we have to close this row and this column. Then we got this and this and this to the minor of A12 and so on. Then we got this.
Okay, as we know before from the previous explanation about the Cramer's rule, we know that the Cramer's rule can be used to solve the system of linear equation. So the Cramer's rule can solve our problem. And here we will try to find the price of each fruit per kilogram using Cramer's rule. So from the problem that we have, firstly, we should change the problem into the mathematical model. So we got a linear equation system. The first linear equation system is J plus 3S plus 3A that equals to 33,000. For the second linear equation system is 2J plus S plus A that equals to 23,500. And for the third linear equation system is J plus 2S plus 3A that equals to 36,500. From here, firstly, to use the Cramer's rule, we change it into a matrix and let the matrix is P, where the form of matrix is like this, where the first row is for the first linear equation system, and the second row is for the second linear equation system, and the third row is for the third linear equation system. And this is for the variable like J, S, and E, where the J is for the orange fruit, S is for the salad fruit, and A is for the apple fruit. And it is equals to the total price that we have from the problem. Like this, 33,000, 23,500, and 36,500. And the next is we find the determinant of the coefficient matrix. We find the determinant using the Cramer's rule. Firstly, we find the determinant of the P, the matrix of the P matrix. Just the P, and we have this. We find the determinant using the minor cofactor, like we have studied it before, using the minor cofactor, and we use the first column for first column cofactor. Like this, we have the A11 times C11 plus A21 times C21 and plus A31 times C31. So we can conclude that we use the first column. And here we know that for the cofactor is minus 1 power I plus J, where the power is power the row plus the column. So because we have 1, so this is becomes 2 because 1 plus 1. And for this is 2 plus 1. So we have 3, and this 3 plus 1, so we have 4. For the minor like this, we minor 1, 1. So we eliminate the first row and first column. For this, we eliminate the second row and first column. And for this, we eliminate the third row and first column. So we can get this. This is from we eliminate the first row and first column. We just have this, so we can get this matrix. And for this is the same. We eliminate the second row and first column. So get this, and this is same as before. We eliminate the third row and first column. So we have this where we just substitute where the A11 is 1, so we substitute this. A21 is this, so we just substitute 2. And for the A31 is this, so we substitute 1. So we just can calculate this where this is this is the determinant from this matrix. So its determinant is with 3 times 1 minus 2 times 1. So we get 3 minus 2. And this is the determinant for this. And this is also the determinant for this. So we can calculate this. It is become 1 minus 10 plus 1. And this is equal to minus 8. And then the next is define the determinant of other matrix for the px, py, pz by changing the variable column with a constant in the system of equations. So that will be obtained determinant of px, determinant of py, and determinant of pz. And first, because we have the first variable is j for the orange fruit, so we have the pg, where the matrix is like this. It is the same as this, same as the P matrix, but we change the first column with the price that we have. We change first with the price, so we have this matrix, and we find the determinant same using the minor cofactor. Here we use the third column of cofactor. So in here we have A13, and this is for the minor is M13. So for M13, we eliminate the first row and third column. So you can get the matrix is this, and this is for the matrix minor. For the minor 2, 3 is we eliminate the second row and third column, and this also for minor 3, 3 is third row and third column. So we can get the matrix is this, its matrix is like this. And to find the determinant, we're still using like just time it like this, but so this and minus, and we calculate all of the formula that we have, and we have it equals to minus 48,000. And for PS, where it is for PY, because the second variable that we have is S for the salad fruit, so the PS is the same as PG, but the price we change the second column with the price. If for the PG we change the first column, for PS we change the second column. So we change the second column like this, and we find the determinant using minor cofactor, where we use the minor cofactor is the first column. We use the first column like this. We have A11 times C11, A21 times C21, and A31 times C31. So we use the first column for cofactor. So we eliminate these first row and first column for the minor 1, 1, and we eliminate the second row and first column for the matrix 2, minor 2, 1, and the third row and first column for the minor 3, 1. And we have this is from the determinant same as before. So we can calculate this, and we get it is equals to minus 3 to 32,000. And the next is for the PA. It is the same, but we change the third row. We change the third column with the price. As before, for PG, we change the first column, and for BS, we change the second column, and for PA, we change the third column with the price. This is the same. We find the determinant using minor and cofactor, where it is using the same, still the same if first column cofactor. So we have A11 times C11 plus A21 times C21 and plus A31 times C31. So it is still the same. To find this, still the same as before. As we know before, we eliminate this and this for each minor, and we cut the matrix is this. And for this, we find the determinant from this matrix. This is from this matrix, and it is also, and when we calculate, it is equals to minus 60,000, because we already have the PJ, PS, and for the PA, so the last is find X, Y, Z. So we can find the J, S, and A. For the J, we find it with, it is the determinant of PJ over determinant of B. So it is equals to minus 48,000 over minus 8,000, and we have 6,000. For the S is the same, so we use the determinant of PS over P. So we have the minus 32,000 over minus 8,000, and we have 4,000. And for A is, because we have PA is minus 60,000, so we minus 60,000 over minus 8,000, and we have 7,500, because we have J is 6,000, S is 4,000, and A is 7,500. So we can conclude that the price of each fruit per kilograms are, the orange is 6,000 in Indonesian rupiah per kilogram, salad is 4,000 per Indonesian rupiah per kilogram, and apple is 7,500 Indonesian rupiah per kilogram. And that's it, how we solve our problems with using the Gauss elimination, and with the last is Cramer's rule. Thank you for watching, and see you.